When considering chemical reactions in aqueous solutions in a quantitative manner, the concentration of the reactants is generally more important than the actual amount of moles of reactants present in the solution. In this video, we're going to develop our understanding of concentration, and in particular one way of quantifying concentration, and that is the molarity of a solution. In general terms, concentration refers to the amount of dissolved solute in a specified amount of solvent or in a specified amount of solution. In the former case, we can express that mathematically as concentration equals the amount of solute divided by the amount of solvent. In the latter case, we can express it as the amount of solute divided by the amount of solution. In terms of the amount of solute, we can quantify that via moles, and moles is the SI unit for amount, but you will see concentration terms and concentration units where mass is used for the amount of solute, and even volume when the solute is a liquid solute. In terms of quantifying the amount of solvent, typically the volume is used, and typically it's litres, but again you will see the amount of solvent or the amount of solution expressed not only in litres but also in mass quantities. The concentration we're interested in is the amount of solute divided by the amount of solution, and in particular we want to quantify the amount of solute in terms of moles and quantify the amount of solution in terms of litres. When we define concentration in this way, it's known as molarity, and molarity with a big capital M as its symbol equals the moles of solute divided by the litres of solution. The units for moles being moles and the units for volume in this case here being the litres. Molarity equals moles on litres. Units are moles per litre, moles/L or MOL dot litres to the -1, but you will also see the capital M being used and the term molar. So a concentration that, a solution that has a concentration of 0.5 moles per litre is also sometimes expressed as 0.5 molar with the capital M unit as the symbol there. So molarity equals moles on litres. So this is an important new relationship that we have to use, almost as important as our molar mass relationship. And like the molar mass relationship, we're going to need to rearrange this equation. So if I multiply both sides of this equation by litres, I can make moles the subject of the equation, and I get moles equals molarity times litres. If I take that second equation and divide both sides by molarity, I can make litres the subject of that equation, and the amount of litres would equal moles divided by molarity. So let's look at a typical example of how we would use the molarity equation. Calculate the molarity of a solution made by dissolving 26.9 grams of sodium sulfate in enough water to form 225 millilitres of solution. Now make no mistake about it, when we're calculating molarity, we need both the moles and the litres. And unfortunately, this question gives us neither. It does give us the mass, and we know that we can relate the mass to the moles through the molar mass equation. So 26.9 grams of sodium sulfate can actually be converted to moles of sodium sulfate by dividing by the molar mass of sodium sulfate. We also know that the 225 millilitres can be converted using our unit conversion approaches into litres. And so we're going to have to do both those steps in order to calculate the molarity. So step 1, calculating the moles of sodium sulfate. Moles of sodium sulfate equals mass of sodium sulfate over the molar mass of sodium sulfate. So we've got our 26.9 grams, and we need to divide it by molar mass. Very quickly, the molar mass would be 2 times the molar mass for sodium, plus 1 times the molar mass for sulfur, plus 4 times the molar mass for oxygen. And that's 142.0 grams per mole. We can substitute that into the equation, and When we put those numbers into our calculator, we get 0.189 moles of sodium sulfate. And we can then substitute that into our molarity expression, 0.19 moles now divided by the litres. Step 2, the unit conversion. What we want to do here is convert our 225 millilitres into litres, and the relevant conversion factor here is this 1 litre divided by 1,000 millilitres. Now, 1,000 millilitres and 1 litre are identical quantities. So in effect, we are multiplying the 225 millilitres by 1. The point here is, by having this conversion factor of 1 litre over 1,000 mils, is that we will cancel out the milliliter unit and we'll just be left with the litre unit. So 225 times 1 over 1,000 leaves us with the 0.225 and the units there being litres. So we're able to substitute that 0.225 litres into our molarity expression. And then the final step there, just calculating the molarity, put those numbers into our calculator, and we get 0.842 moles per litre, which is also known as 0.842 molar. You'll hear both those terminologies.